Now let's solve the following inequality. When we solve this inequality, negative 4x plus 7 is bigger than 31. Just like in solving an equation, we want to try to isolate x. And so we're going to be undoing operations. We will first want to undo the addition of 7, just like in an equation. So we will subtract 7 from both sides. So 31 minus 7. And plus 7 and minus 7 cancels, leaving us negative 4x is bigger than, and 31 minus 7 is 24. Now, what's the next step? Well, since x is being multiplied by negative 4, we should divide by negative 4 to undo that multiplication. So negative 4x divided by negative 4, and 24 divided by negative 4. Now, because the number we're dividing by is negative 4, right? This is a negative number. And we have the rule that says when we divide by a negative number or when we multiply by a negative number, we have to reverse the inequality sign. So instead of keeping the sign as greater than, we will reverse it to a less than. Again, this is because the number we're dividing by on both sides is a negative number. It has nothing to do with anything other than that. Well, those cancel, negative 4 and negative 4, leaving us an x, and that is less than 24 divided by negative 4 is negative 6. And we could plot this on a number line, right? Negative 6 is our key number. Empty circle, because this is a strict inequality, which means that x can't actually equal negative 6. And we shade to the left because x is smaller than negative 6. And there's our solution. Now, just like with equations, we can test to see if our solution is correct. So if we pick a number less than negative 6, and I'll just pick a random number less than negative 6, negative 10. I like 10 because it's an easy number to plug in. If we let x equal negative 10, then 4 times 10 is 40, and negative make a positive, so that's a 40. Plus 7 is 47, which is definitely bigger than 31. Looks like we did it correctly, right? If we, for example, accidentally shaded in the wrong direction, and I had to pick a number that's bigger than negative 6, for example, 0, again, a very easy number to plug in. If I plug 0 in for x, negative 4 times 0 is 0. 0 plus 7 is 7. Well, 7 is not less than 31, right? So that would have been definitely the wrong answer. So don't be afraid to just pick a number in your solution set, plug it in. It'll give you a good idea whether you're probably right or not. Let's take a look at one more inequality. 4x plus 13 is greater than or equal to negative 13. Once again, we do what we've always done. We undo the addition of 13 by subtracting 13 from both sides. The plus 13 and minus 13 cancel, leaving us 4x is less than or equal to minus 13 is minus 26. Here, x is being multiplied by 4. To undo that, we will divide by 4, right? We take the 4x and we divide it by 4, and we take the negative 26 and we divide it by 4. Notice that here the number we are dividing by is a positive 4. It's a positive number. And because the number we're dividing by is positive, we do not change that inequality sign. It stays as a less than or equal to. It doesn't matter that the 26 is negative. The only thing that matters is the number we're dividing by was positive, so that sign does not change. And multiplying and dividing by 4 cancels, leaving us with an x less than or equal to. You can simplify 26 over 4 by dividing the top and bottom number by 2, and 26 divided by 2 is 13, and 4 divided by 2 is 2, and that makes it negative 13 over 2. So that's our answer. X is less than or equal to negative 13 over 2. And once again, I can plot this very easily on a number line by saying that the key number is negative 13 over 2. The circle here is filled in because this is not a strict inequality. It's a less than or equal to, so x could equal negative 13 over 2. Again, x is smaller than that number, so we will shade to the left. Again, if I really wanted to test this out, I could pick a number that's definitely less than negative 13 over 2, like negative 20, for example, is clearly less than negative 13 over 2, right? It doesn't have to be right next to it. It could be much smaller. And if I plug negative 20 in, 4 times 20 is 80. That's negative 80 plus 13 is negative 67. Well, that's definitely less than negative 13, so looks like I definitely shaded at least in the right direction. Let's take a look at one more example. We're going to look at one more example of this. And I just wanted to show you that even with inequalities like that, you treat them just like equations, except for that multiplying or dividing by a negative number thing. You still say we need to simplify what we can, right? So we will use the distributive property. 3 times 8x is 24x. 3 times 9 is 27. There's just the plus 5. Less than or equal to. Negative 4 times negative 2 is positive 8x. Again, negative times negative is positive, and 3 times 4 is 12, plus 6x. We combine what we can. We can combine these numbers, and we can combine the like terms on the other side as well. Just like with equation, we can't combine the 24x with the 8x because these are not part of the same expression. The expression to the right of the inequality sign is not the same expression as what's to the left of the inequality sign. So we have 24x minus 27 plus 5 is minus 22 is less than or equal to 8x plus 6x is 14x plus 12. Now, we have an issue with our x's being on opposite sides of the inequality sign. So just like with equations, we can just get rid of the 14x by subtracting 14x from both sides. So subtract 14x from the left side and subtract 14x from the right side. 24x minus 14x is 10x minus, 22, this isn't or equal to, is less than or equal to. 14x's cancel, we have plus 12. Next, we want to undo the subtraction of 22, so we will add 22. Should say 12 plus 22. So the minus 22 and plus 22 will cancel. I'll continue writing this on the other side. We're left with 10x is less than or equal to 12 plus 22 is 34. And finally, divide the left side and the right side by 10 to undo the multiplication by 10. 10 is a positive number, so we don't have to change the inequality sign. And we're left with x is less than or equal to. We can again simplify the fraction by dividing by 2 on top and bottom. 34 divided by 2 is 17, and 10 divided by 2 is 5. So there is our answer. X is less than or equal to 17 over 5, which, if we wanted to, we can represent on a number line with a filled-in circle at 17 over 5, because this is not a strict inequality. X could equal 17 over 5, and shade left because X is smaller. So there you go. As you can see, as long as you know how to represent your solution on the number line, and you're careful to reverse the inequality sign if you happen to divide both sides of the inequality by a negative number, the rest of this is just like solving equations. So now you know everything you need to start on the next assignment. Good luck.